See Standard 12th Maths Chapter 6. Topic Applications of Vector Algebra. Exercise 6.4. Before start doing the problems from this exercise, just let me give you the introduction of the equations. Vector equation of a straight line passing through a fixed point. Passing through a fixed point. Fixed point with position vector A and parallel to a given vector B. So we are going to find the vector equation of a straight line passing through the fixed point A and parallel to the given vector. So let me take a plane x-axis. See here you take x-axis. Y-axis, Z-axis. So the equation, the straight line passing through a fixed point. Let me take a point A here. So the straight line passing through this point. Take that line as L. And the position vector of this point A is, see, with respect to the origin, OA is vector A. Vector A. See, and also this line is parallel to the vector B. So here, let me take a vector B that is parallel to the given line. So I am going to find the equation, vector equation of this straight line. So take an arbitrary point P on this line and also whose position vector is, we mark it as vector R. Vector R. So here, so A is a point, P is an arbitrary point. So this segment AP is parallel to vector B. AP is parallel to, this vector AP is parallel to vector B. That means any two vectors are parallel means one can be represented as the scalar multiple of the other. So what is this AP? Actually, according to the vector formula, AP can be written as OP minus OA. This is equal to T into vector B. So what is OP? Vector R minus vector A. OA is vector A is equal to T into vector B. So vector R is equal to, take this point A to the other side, A plus T into vector B. So this is the vector equation. This is the vector equation of a straight line. Vector equation of a straight line passing through a point and parallel to the given vector. So vector R, vector R is equal to A plus T into vector B. So this is that, we say that parametric form. This form of representing the straight line is parametric form. Parametric form. So the next one is, we are going to represent the same straight line equation in the non-parametric form. In the non-parametric form. Non-parametric form. Non-parametric form. So what is non-parametric form? So we represent the equation either in the dot product or in the cross product. See, the previous we have seen that AP is parallel to vector B. Therefore, AP can be represented as scalar multiple of the other. And also we know one condition. Since AP is parallel to vector B, So their cross product is 0. Their cross product is 0. So what is AP? AP is equal to vector R minus A. So R minus vector A cross vector B is equal to 0. So this is non-parametric form. We are representing the equation in cross product. Next, third form of representing this is Cartesian form. Cartesian form. So how to represent the Cartesian form? See, you take the given point A as x1, y1, z1 and the parallel vector, vector B as in vector form b1i plus b2j plus b3k. b3k. In all the three direction we take. So and also arbitrary point vector r is equal to xi plus yj plus zk. So this is equal to actually, see directly let me write the equation x minus x1 by a x minus x1 by b1 is equal to y minus y1 by b2 z minus z1 by b3. So this is the Cartesian form of representing the equation of a straight line passing through a point and parallel to a given vector. So let me do the first sum in the exercise. So three forms you have. First one is parametric form. The next one is non-parametric form representing in the cross product form. Then this is in the Cartesian form, third form of this. Let me do the first sum in the exercise. See the sum. Find the non-parametric form of a vector equation and Cartesian equations of the straight line passing through the point with position vector 4i plus 3j minus 7k and parallel to the vector 2i minus 6j plus 7k. Here the point is vector A. Vector A, that is 4i plus 3j minus 7k. And parallel vector, actually we represent this in B vector 2i minus 6j plus 7k. So we are going to represent this in non-parametric form and Cartesian form. So the first form is actually parametric form that they are not asked here. But anyway, let me just mention you parametric form. Parametric form. See, first form, parametric form is here vector r is equal to a plus t vector b. Just write that. Vector r is equal to vector a plus t vector b. So vector r is equal to 4i plus 3j minus 7k plus t into vector b is 2i minus 6j plus 7k. Now come to the non-parametric form. So this is the answer. Next is non-parametric form. Non-parametric form. So what is non-parametric form? Representing in the Cartesian product vector r minus a cross vector b. So vector r minus a cross vector b is equal to 0. So substitute that r vector. R minus a vector is here 4i plus 3j minus 7k cross vector b is 2i minus 6j plus 7k. That's all. This is the answer. Is equal to 0. This is the answer. Third one is Cartesian form. Cartesian form or Cartesian equation. Cartesian equation. So what is Cartesian equation here? X minus x1 by b1. X minus x1 by b1 is equal to y minus y1 by b2. Z minus z1 by b3. What are these b1, b2, b3? They are the vector terms, parallel vectors. They are parallel vectors. So which is a parallel vector here? B is equal to 2i minus 6j plus 7k. 2i minus 6j plus 7k. So this is your b1. b1 is 2. b1i plus b2j plus b3k. Just you take the coefficients. So what are this x1, y1, z1? It's a point. Vector A, point. Passing through the point 4i plus 3j minus 7k. This is our x1i plus y1j plus z1k. So just write this. Replace x1 as 4, x minus 4, b1 as 2, and then y1 as 3, y minus 3 divided by, here b2 is minus 6. Then z minus, what is z1? Minus 7. So already one minus here, so plus 7. Plus 7. Divided by b3 is here 7 by 7. So this is the Cartesian equation of a line. So I represent in 3 form. They ask you, they didn't ask you a parametric form, just you know the idea. Non-parametric form and Cartesian form. Let me do the second sum. See the second sum. Find the parametric form of the vector equation and Cartesian equation of the straight line passing through the point minus 2, 3, 4 and parallel to the straight line. X minus 1 by minus 4, y plus 3 by 5, 8 minus z by 6. See, when you need to find the equation of the straight line, here one is parametric form, another one is Cartesian form. We need a point and a parallel vector. But instead of giving the parallel vector, they given it is parallel to the straight line. So our line is parallel to another line. So in that case, both the lines are parallel to the same parallel vector B. So here the denominated term is the terms of the parallel vector. So the passing through the point A is here. Point is minus 2, 3, 4. And our parallel vector B is here the same as the given line. So minus 4i plus 5j plus 6k. So both the lines are parallel to the same vector. So therefore for our line, the line is passing through the point and parallel to the vector. First one we need to find parametric form. Parametric form. So parametric form is equal to vector r is equal to a plus vector a plus t into vector b. So t is a scalar. T belongs to some r. So a is here minus 2i plus 3j plus 4k vector k plus t into b vector is minus 4i plus 5j plus 6k plus 6k. So this is the parametric form. Next is Cartesian form. Cartesian form. So x minus x1 by b, b1, y minus y1 by b2, z minus z1 by b3. So point is here minus 2, 3, 4. So x minus 2. So plus 2 by then y minus 3 by b2, then z minus 4 by. So b1, b2 minus 4, 5, 6. So here minus 4, 5, then minus 6. So this is the Cartesian form or Cartesian equation. This is the required equation. So I have done two sums. The same model. Just you be thorough with the vector equation in parametric form and non-parametric form, and then Cartesian form. Parametric form vector A plus T vector B. Then non-parametric form R minus vector A cross vector B. Cartesian form x minus x1 by b1, y minus y1 by b2, z minus z1 by b3. So you be thorough with this and then you can do the problem. Thank you.